I'm Sarah Smith, and I'm hoping you guys are all here to hear about coding stunning mobile applications. I'm going to be talking today about some of the more esoteric, sort of cutting-edge technologies that are in Qt, maybe because they're only here relatively recently. I'll be looking at three sort of techniques that I'm really hoping will help you make your applications cutting-edge. My background, I've been with Trolltech and then Nokia since 2004. I'm a senior engineer based in the Brisbane office of Qt Development Frameworks. And in my day-to-day work, I'm doing OpenGL programming, working on the Qt 3D project. Has anybody here downloaded Qt 3D from the labs repo and tried it out? No, it's super esoteric. But it's there, and we're hoping to have a release in the next month or two. It'll be a separate module from Qt proper. And if any of you attended my talk yesterday, I talked about our QML bindings for Qt 3D. This talk is going to require some knowledge of C++ programming, so I'm assuming most of you guys are applications programmers, or at least interested in apps programming. We're going to be talking today about C++, not so much any kind of scripting or anything. And we're going to be talking about some of these more cutting-edge, more interesting parts of Qt. Now, I'm hoping you guys can work with me a little bit, because as I try to go through this material, there's a hell of a lot of it. I've got a chance now to get up on my soapbox and say what I think is cutting edge, and what I think we need to do to make these great applications that are going to be compelling for people on their mobile devices. So to try to bind all this material together, I'm going to work with a metaphor about a show, right? I don't know how many of you guys, pretty much everybody's got to have been at least in the school play, or maybe you work with, in your spare time you do some music. So we've got the stage, right? The front where our adoring audience sees the fruits of our labor. But then at the back, we've got all the machinery, guys pulling ropes and trying to make it all happen. So I'll try to use that to tie it together, and metaphors in programming, like, the word thread, that's a metaphor, right? There aren't actually any threads. These metaphors can be useful, but we'll see where we go with it. So, all right, here's the acts in our show. We're going to work together a little bit to try to decide what is stunning. I've got my own ideas, but I want to hear from you guys. Then I'm going to look at that back room, the backstage guys, that's you and me, C++ developers, working, hard to try to make things happen. And I'm going to just do a little bit of my soapbox thing about maybe some stuff you heard back at university about how to do some software engineering. That's going to be very short. Then I'm going to get into these three techniques. I'm going to be covering, first off, OpenGL Shader programs, very, very briefly, mostly just so you know they're there. I won't have time to talk too much about exactly how you would use them, but just give you some general ideas so you could start researching it. I'm going to look at states and transitions, not the QML ones. These are the ones that are in C++. And as it happens, the QML guys actually wound up using their own implementations. But in C++, you can still get the same groovy effects. And the last one I'm going to talk about is threads. Throughout this, I knew you guys would not believe me if I was going to just come out and say, hey, use this stuff. So I thought, well, gee, I'm going to have to come up with a demo. So I quickly tried to cobble something together. Now, we're talking about stunning apps. Apps are real programs. My crappy demo is not an app. So it's going to be a little bit of a case of do as I say, not as I do. But I'm hoping this demo, and I'll show you where you can download the code for it. It just ties these three things together and shows how they can work to create an app. Now I'm going to ask you to save your questions for right at the end. We're going to go through a lot of material, so I'm just going to quickly work with it. If you see some kind of glaring problem, please shout out. And in particular, I have a lot of material, so I'm going to start with some generalities and then drill down to more specifics and actually show some code. If you guys are yawning, you want me to move on to the next thing, just give me the rah-rah and I can breeze on to the next topic. All right. So, stunning applications. We're all pretty much developers, maybe a couple of designers in the room, I'm not sure. But, you know, there's this idea of a stunning application, something that has that kapow factor, the sort of thing that makes us want to download it and try it out. But, you know, as engineers, do we really understand what stunning means? Right, it's a question. So, you know, we want to resolve this question in terms of numbers. You know, is it frames per second? If I get 50 frames a second, it's stunning, right? Automatically. Well, maybe not. Maybe it needs cool graphics. We'll try to think about what this is. In a second, I'm going to ask you guys to try to come up with some ideas about what stunning is. So maybe stunning is good, right? We want stunning good, not stunningly bad. Maybe we could also think about what it is that makes things really dreadful with an application. I'm sure most of you guys have downloaded some clunker from, you know, some app store, or tried some, maybe even built something yourself that didn't work out so great. So think about that. And we're also going to look at who is it that counts, right? Who is being stunned here? I mean, I write my own app and oh, wow, I rock. That was such an awesome app. Do I count? You know, this is my opinion. Okay, some other people has to be stunned as well before we get our paycheck. Okay, so we're going to just have to scream this out. We won't be able to pass the mic around. Some ideas. What's a stunning application? What is it that makes it stunning? Thoughts? Unexpected. Okay, so like innovative, you mean, and new? Uncommon? Yep. Responsive, that's a good one. Yep, keep on shouting them out. Function. It has to work, has to do something. That's what you mean. So functionality is, it delivers as well, right? Okay. Simple, that's a good one. Yeah. So simple to use, simple to understand. Great. I heard UI. There was another one over here somewhere. UI, yeah. Intuitive. Yeah, that's a really good one. Okay, and who has to think that it's simple and responsive? The user, yeah? Your boss, maybe? No? He doesn't count, right? Don't care about him. All right, well, this is looking pretty good. I think my scorecard, I'm hopefully not too far from the mark. I think we're on the same page here. We've got something innovative and new, right? Something that does something pretty cool. It provides functionality that we're after, and it's responsive. Simple and easy to access, easy to get started with. So maybe I wasn't too far off. My picture is we've got this guy, right? He's our user. He's right at the center, and everything revolves around him. That's the base before we even care about this other stuff. And I think I didn't want to have these three things in any kind of order, put one before the other. So what I'm going to say is that we have a responsive application, and it's responsive to this guy, right? He's just waiting for the bus or something. He needs it to happen in the next few seconds, and he's got some task that he's trying to do. What I'm saying here is this function, right? I didn't want to frame this in negative terms, so I didn't want to say don't put all this extra detail, you know, the weather, and turn your whatever it is into an email client, but stick to what it is that it's supposed to do, so it's simple. There's not a lot of stuff crammed on that screen. Task-oriented and graphical. With stunning applications, obviously, you maybe have your team of artists, your UI guys, and they're going to help you produce some nice assets that are going to dress up your application. But that's not all graphical is about. I like that word because it's overloaded with extra meanings. You know, Quentin Tarantino did all those graphic movies like Pulp Fiction, you know, had punch. There's a lot of emphasis. We reduce things to a few essentials. That's what graphical means. It's almost diagrammatic, right? So those are the things. I think we're on the same page here with this stuff. So, all right, let's just move on a little bit. I'm going to try and give a bit of a demo. Now, I'll just have to flick the screen around. Production guys, is there any way of just making the lights at the front of the stage just a little bit dimmer so that we can see that screen a little bit better? Now this is this demo program. No luck with making the lights at the front dimmer at all? Okay, so that's going to be just a little bit gloomy, I'm sorry. Okay, so what we've got here is our sort of demo application. And wow, you know, like this whole sort of 3D alpine world that we can see, you know, pretty impressive, right? Well, I'm impressed. I wrote it, so I'm... No, okay, I don't get too impressed. I forgot we already established that it's the user that has to care about it. So, yeah, so this is our application. How many polygons must be in those mountains? You know, those lighting models, that's incredible. Well, actually, no. What I really did was I used a thing called a skybox. And, you know, this is kind of cheating, right? What I really did was I set my camera up right in the center of this box, and I turned off depth testing, and I just painted these mountains on the back sides, and it doesn't matter which way you pan around. I glued those images so that there's no seams, and it looks like a mountain, but actually, no, it's just kind of a fake. But this is the flip side to this thing where we're saying what we care about is how the user perceives our application. This is actually a good thing because when you can get away with it, fake it. You can be the fakingest faker from Fakesville, because what really counts is that user experience. You provide the functionality. You give them the ability to achieve the task that they want. Apart from that, you know, as engineers, the first thing we think of is, all right, well, I have to display all of this stuff, and I have to make it all available. And, well, really, no. Concentrate on the essentials. And sometimes what falls out that all the user needs to do for their job is, you know, look at flick lists, for example. If you've just got placeholders either side, maybe that's enough. All right, I won't dwell on that point too much, but it's not all bad news when we're talking about having to work with this user guide that we're caring about here. Okay, so this is the part where I get up on my soapbox just a little bit before I get into these three technologies. I'm just going to talk a little bit about software engineering. Like, you know, I've been doing software engineering for 12 years now. I've been with Qt for 7 years. And, you know, we start to get where we know it all, and someone says, look, get this thing done quickly. And, you know, if it's just a demo, some kind of prototype, some quick thing, it's just a throwaway, well, maybe that's okay. But don't throw out all those principles of software engineering. If you make things with reusable components, it's going to be much easier for your stunning application to still be stunning when it gets to version 1.2. If you document these components, you've created some incredibly responsive back end that delivers the data to your user interface. If that's maintainable, you get to reuse it, and it can be part of other applications. One of the things I'm going to talk a little bit about when I get to threads is the idea of internal contracts and creating APIs inside the structure of your program. This is part of documenting that code. Even if you're initially maybe part of a very small team, you may feel there's no point in documenting a lot of this code. There's no library here that people are going to reuse, at least not now. Why would I waste my time when I've got deadlines? But, you know, if you separate out your application, not only can you obviously make it more testable, but you can document these contracts and later on, maybe a designer comes along that wants to do some renovation of your program and make it look better. If you've just got a few points that allow some of that integration to happen, 1.2 can have a whole new fresh look, and that's a chance for that creative input to drop right in and freshen up your program because you separated things out. All right, I'm not going to throw the duster at you guys. You know how to do software engineering, so I've thrown those points up there because I think they're worth saying, but we'll press on to the first of these technologies. Now, as I said, as I go through these three topics, I'm going to start off with some generalities, then I'm going to drill right down, and I'm going to try to basically, go from the front of stage with that front stage, back stage idea, right down into the details, what you see, and then how it is you get that stuff. So OpenGL Shaders. I work daily with OpenGL, and shaders themselves are perhaps a difficult and fraught topic. It seems like black magic, but I'm just going to raise a few points here to try to give you guys some ideas about how you could integrate shaders into your application to get some performance. Now, don't worry too much about all that blurry text up there. What I want to really get across is the idea that you've got these little tiny programs that look very much like C code. They have syntax, they have structure, just the same as your C programs. And in particular, we've got a little magic variable here. This one's GL frag color, but don't worry too much about that. And what these magic variables allow our little shader programs to do is communicate to each other. We have a pipeline, the OpenGL rendering pipeline, and in the top end of that we have our data model. Maybe it's some kind of compelling 3D world, or it's a representation that you're going to show to the user in your stunning application. That structure comes down our OpenGL rendering pipeline as a geometric representation of triangles. And the first thing it hits is our vertex shader. Now, as these little vertices arrive there, our vertex shader has the chance to jump in, and it's very much like a plug-in framework. It can manipulate vertices, even construct new ones, move them around. And then the output from that is a GL vertex, one of these magic variables, and that then continues on down our pipeline, all massively parallelized on our big, powerful GPU. In fact, I sometimes think that pipeline is not a great word. It's more like one of those deluge showers where you pull the thing and there's this big shower of water coming out. It's sort of super parallel, lots of pipelines all running down at once. So it's always valuable. Our little tiny program here is going to be executed thousands of times, at least for every pixel on your screen. And there's pretty hard to match that performance, even on a small device like this one. We have the SGX chipset, which has an OpenGL ES implementation. Same deal. We've got access to some pretty nice acceleration. So what do you need to know about shaders? Basically, that it's a chance to put some functionality that can massage your world model and change the way that model is rendered onto the screen in terms of pixels or fragments. Now, what you can see here is a very common type of tool that a developer might use when they're working with shaders. They've got their two shader programs they're working there on the left, and I'll show you one in a sec. And on the left is the actual result of mapping those shader programs onto an object. So one thing I will say about shaders is that they can be very platform dependent. QGL shader program, which is in Qt 4.6, helps you get around a lot of that stuff. But one of the things you probably want to do when you're working with shaders, especially for an application that's going to have a bit of lifetime, one that's going to run on a number of different devices, try to identify the particular vagaries of the shader. If you heard Gunnar Sletter's talk the other day about the scene graph, there's problems with the way varying values get interpolated by the SGX as we pass information from the vertex shader to the fragment shader. It turns out to be very expensive. So, and also Power VR, they make some particular tools for their chipsets. If you use their shader management stuff, their texture compression stuff, you're probably going to get a better result. But obviously at the cost of some portability. So if I just give you a little quick idea, try to make this concept of shaders just a little bit more real. Obviously, as I mentioned, you want to use the most optimal thing for your platform, but I work with Mac every day. That's my development platform. So if your desktop machine comes with some nice OpenGL tools, then that's the place to go for it. So here I have the Mac inbuilt Xcode shader development environment. And I've got my two little shader programs. These are a lot more simple than the ones you saw there. So here I've got my vertex shader, and it's just simply taking in the GL vertex value, which is one of these magic values of all my triangles. So I have a big model on the screen of a teapot or a penguin or whatever, and maybe it's got 5,000 triangles. It might have, you know, less than that number of vertices. And each of those gets modified by our projection matrix and results in a position. And that's going to come in and get interpolated across by our deluge shower into our fragment shader here. And then I can apply the value to pick out from our texture, our color of a thing that we're going to stick on our teapot or whatever it is, to actually produce the final color. All right, so this is Apple's shader editor, and it's got this little feature here where I can actually animate a value. So I decided what I'd do is I'd stick in this little offset. Now, if you take one idea away from this shader presentation, if I want to infect you with the idea of, okay, I'm going to get excited and research shaders, it's this idea of uniforms. So, you know, we've got our engineers and we're backstage pulling on the ropes to make all these elements of the show sort of appear and everything. This uniform is like our lever. This gives us the ability to control whole entire thousands of vertices, all by just changing a few little switches. So that's the value of that. What you can do is create a shader program where you've got this value that's just going to animate. And then if I show the rendering of that, what that's doing is just modifying the texture value. So normally copying texture around in normal CPU memory would be incredibly expensive. This costs almost nothing. So if I brought up my CPU monitor right now, you'd see it on 0% pretty much. So all of that's just happening on the GPU. And on the CPU side, all I have to do is just alter this one lever, this GL uniform value, that's going to drill down into my texture. Okay. So that's working with shaders on the desktop. I don't know if any of you guys were in my QML 3D presentation, but another thing you can do is download our Qt3D Labs repo, and if you want to get on the cutting edge, have a play with that. With QML 3D, you actually have this nice little idea of being able to use our scripting language to play around with shaders. Let's see if I can hopefully, if the gods of demos are going to be nice to me today, and actually run that demo. This is a similar kind of thing where we have two different textures uploaded onto the GPU, and our uniform is just slowly interpolating from one to the next. And it's doing this all on the GPU, even though this is written in QML. The scripting side of it doesn't have to iterate during this. It's basically pulling on one of those uniforms to change the value, and we can actually do that with a script, because let's just have a quick look at the QML that does this stuff. So here I imported our Qt Labs plugin and created in QML a shader program where I've applied an animation to a interpolation factor. And then inline inside of the QML, I've got a couple of fairly simple sort of shaders. And down here in my fragment shader, where I receive the texture itself and apply the texture values, I'm just modifying that interpolation factor between these two different textures. Now this interpolation factor is just a high P, relatively small value, and that's just being set by the C++ in the background. So the scripting is telling it, all right, I want to animate that as part of a sequential animation. So even though this is a QML script, we get not bad, reasonable performance on a 5-year-old MacBook Pro. Okay, so just really to try to make a picture out of that, if we want to use shaders, we create a huge amount of data with our, whatever it is, our models. Maybe we've got a 2.5D type thing where we want to have some basic sort of images stuck on the front of some stuff. And those triangles, whatever they are, we stick them up on the GPU, and then we just modify these uniforms. And those controls give us the ability to harness the power of the GPU to produce some nice effects. You can probably make a set it and forget it type approach if you've got access to some creative people who have got some nice shader based stuff, and then you can just drop those uniforms into those shaders without a lot of research into stuff. And just drilling down into a bit more material, the thing that's going to make this, a bit more code, I'm sorry, the thing that's going to make this easy for you, hopefully, is our OpenGL Shader program. So I'll just show you what the shader program does. I'm looking at some code. So here's my what my program does, the demo that I produced. Now I've used a OpenGL Shader program here, and what it does basically is takes out all of the headaches that you normally have when you're trying to work with OpenGL Shaders. Normally you have to bring in the text somehow. I have my shaders loaded up here as just little resources. I pull them in from source. They get compiled and linked just by a few lines of code. And here I'm actually binding those uniforms into the shaders so that I can later refer to them and change them around. What this code is actually doing is I've implemented a basic level of detail type system. So when I run my little demo, this is, you could imagine that this might be a photo browsing application, right? And as I have the camera move further away from these textured images, it's actually going to start using an atlasing approach to actually save on texture memory. So I don't need as much detail. You could use some sort of nip mapping, but even there you're running out. So what I did was my atlas, when it's just a little thumbnail as part of a larger one, I've written the word thumb across it in orange. And you can see that what's happening here is that if I've got my thumbnail set up, it's, where are we? Okay, so here we are. I changed my thumbnail variable in my uniform, and it's just going to flick a switch so that I get I've got all of my texture attributes set up in one set of OpenGL attributes passed to my shaders, And then the second set is the thumbnail ones, which index into this big atlas of texture data. A little bit of extra detail, but the general idea is that just by flipping this pointer, essentially, I can select between these two large blocks of data without having to have any traffic across the bus to the GPU. So that's thumbnails, at least I'm sorry, that's OpenGL Shaders. Won't dwell on them too much more just now. Anybody spot any glaring problems, please sing out, but otherwise we'll save our questions as we move along. Okay. Okay, now I'm going to look at states and transitions. These were added to Qt not that long ago, I think in 4.6, so they're relatively new. The idea of a state is maybe a little bit tied to this concept of animations, especially if you've come from the QML world. You might think, well, you know, I've got a few states in my program, but I'm just going to start coding C++. I don't care about that stuff. If I want some animations and funky stuff happening, I can always glue that onto the UI later. That's for those UI guys to care about. But what I'm going to say is that if you start thinking about states right up front when you are designing your application, it's going to give you a head start because you're really looking at user interaction drilling right down through the structure of your program. So in the program that I showed you just before, we've got really three states. What it does is when it opens up, you've got that mountain scene and you've got a big girder floating in space. You're in the browse state, right? Then there's a pan state. So if I click on some of the little buttons, it's just going to start streaming the I'll show you the demo in a minute. It's going to start sliding across, it tilts the camera, and you slide down this girder, panning across all the photos. And then finally there's a focus state. And of course you can move between these states. If you are in the browse state, you can get to the pan state. But as you can see from this, you can't get directly from panning to this drilled down focus state. You have to go through browsing first. So even from a theoretical point, maybe this has had some value already, just drawing these circles on the screen. I can see how my app is going to be structured. The way to work with these things really is to get out a big sheet of paper and maybe get your buddies around the whiteboard and actually start doing some of that design. Get your initial concept of what you want to achieve. These are your functions. You know you want it to be simple. It's just going to be a few basic tasks, and just kind of maybe create a little bit of a cartoon out of it, storyboard it across so you can see what's going to happen. You might be uncomfortable with some of these ideas. Maybe you think that's something that just the UI guys could do. But if you start this stuff up the front, you really are going to make it a lot more compelling when your application actually has to communicate with the screen. Okay. The other thing is that with the concepts of animations, as I'll show you in a minute, we've got the entire Qt state framework. You can glue those animations on there to get some nice effects. A lot of things can be tweaked after the fact. So the curves and transitions, how fast an animation executes, and so forth. You can alter a lot of that stuff if you actually set it up that way from the beginning. But you know, if that's not there, it's going to be very costly if your UI team comes along and says, look, I'm sorry, your application can't be saved. It's, you know, we'll give it the humane injection. And, you know, it's much better to start off with an approach where, you know, you haven't designed in a bad interaction right from the word go. And storyboarding your states can actually help a lot with that. So I'll stop with some generalities and start drilling down to how we get backstage and make some of this happen. This link goes to the state machine documentation on Qt. So if you've never read up any textbooks about how state machines work, read the excellent documentation that they've got there. There's a few pages of it, but it lays out really nicely how you can use states. The basic idea is that you can construct some states for your application. You can group them, connect the transitions together. You can create child states that operate down inside. So if I can just flip this over, the way my demo application works is we've got these 3 states, and they all exist inside an app state. So when my app is running, we're all inside here, but if I trigger a quit, what's happening, I'm going to transit straight from any one of these 3 to here. So these are child states, this is a parent state, and all of this stuff more or less happens mostly for free, just with connecting up some signals and slots. Once you've done that, the general idea is that you wire up all these animations to your transitions, and this is very embarrassing, but yeah, you actually have to start your state machine. I actually managed to forget this. The symptom of it is you run your program, nothing's happening. There's no events being emitted, there's no event loop. It's terrible. So yes, don't forget to start your state machine. All right. So we'll just have a real quick look. I'm sorry if we're getting some sort of jittery effect when I switch from screen to screen, but I think it's worthwhile just having a real quick look into the code here. So here's my code where I set up all my states. I've got my main state machine at the top. Here's my Q app. And within that, I have these 3 states. I'm going to set the browse state to be my initial one, and I add my app state to my state machine. So that's the basic setup. I've created everything. Now I'm going to actually start connecting some stuff up. When I get the done signal from my UI, I travel to the end state, and that quits my application. I've done some funky things here so that my 3D world can be operated by these levers, my state machine. I've created a focus adapter that has a progress property on it. And as progress goes from 1 to 0, I actually zoom in. So like that. That's my focus adapter working. So what I'm doing there is I position the camera, I capture the thing that I clicked on. See if I'm in luck and this one works. Yeah. So it's that focus adapter is a way of taking the 3D objects and actually applying my state animated transition to them. I put some debug output here, just I won't drill down into that now unless someone's really excited about seeing all my debug output, but you can actually see it moving from state to state. One thing with states and transitions is it's very tempting if we're used to, getting hold of the thread of control by the throat and, I'm in charge here, I'm going to tell these state machines, I go, if I'm in this state, then do this, then if I'm in another state. That doesn't work. That's really not what state machines are designed to do. What they want you to do is wire up signals and slots and animations and have the state machine push out those messages. So they're actually going to control your whole application. That's the idea of how they work. It's a lot more of a declarative way of programming, and it works quite nicely with Qt. Okay, so I won't spend any more time on state machines at the moment. I'll breeze on to the last of our technologies. Okay, so threading. These days when I read the news, the tech news over breakfast, there's a lot of stuff about multi-core. And, when I started back in 2004, if I would have talked about multi-core cell phones, people say, oh yeah, well, you know, I have the application processor and, you know, maybe have a modem and stuff, it's all on there. No, surely we have, you know, multi-core phones. You know, people would think I'm, you know, from another planet or something. But yeah, it really is, it's all happening. I think the message really that we want to start talking to our workmates around the coffee machine is, well, hey, is your application going to take advantage of all of the cores of the devices and the machines that are out there? Certainly on the desktop, it's going to be pretty hard to find some kind of machine that you're targeting that doesn't have multiple real threads of execution happening. Even with a single CPU, there's still some value in it, but it's becoming especially important. So what I want to say is that if you're going to ask yourself, when do I need to start worrying about threads? Well, yesterday, you know, really get it on. It is something that we can't really escape. I know most people that I talk to about threading, it's like, yeah, can I go to the lecture where I find out how to not use threads? Just tell me, you know, what do I have to do? I'll do anything. Let me off the hook. You know, well, of course you can take the performance hit and your UI is going to block as soon as you start loading some kind of big file. That's one way. Or you can do what we used to do in the old days, which was we would create some kind of timer event and it would fire. And we could almost imagine that we had some sort of multi-processing going on because it sort of looked that way, right? We had a timer would fire and we'd do a little bit of work and then we'd pass control back through the queued event loop. And, you know, we'd sort of be doing our own time slicing and it's sort of vaguely threadish. Well, really it's not. It's actually your own manual approach. And how big do you make those time slices? Yeah, so you can't outguess the kernel. The kernel is much better at doing that job, and of course all that stuff is really happening in the same thread. So what I'm going to do in the last few minutes is I'm going to suggest that you homies follow my rules for threads. I'm going to have to whiz through this a little bit. But my suggestion is that, these are some general ideas, this works everywhere, is, like I said at the beginning, document your code with some invariants. This variable will only ever be altered in this particular way. So you guys can take charge by telling future self and other people maintaining your code that, you know, stuff is under contract here. Don't do stupid stuff. Your documentation can take the form of an assert, if you like, where obviously that's going to vanish at, when you compile for release, but it's still pretty valuable stuff. Use some good design patterns. There's some great ones out there. I have some links to some textbooks on my last slide. Atomic data is really good, and Qt helps you out here with a few different classes. The queue is a really handy structure for writing threaded code. You put stuff on the beginning, take stuff off the end, and I don't really care what order that stuff is in. You can solve some of the classic problems of dealing with concurrency by using a queue. Obviously, the underlying data structure has to be thread safe itself, and the Qt queue is not naturally thread safe because we don't want to make that performance decision for you. You're going to have to apply a little bit of locking there perhaps. But I'll tell you a way to get queues for free. And take away from this slide for my rules is that a really good approach is to create some kind of background manager object. So we've got our front of house, and then backstage we've got some guy that's directing everything, telling everybody what to do. And this is the guy who's going to basically not do any work at all. He's just there to pass messages. And I'll show you how he works in a minute. But this is the one that's going to manage your queues. It's going to dish out jobs in your thread pool, create leaders and followers, and so forth. It's quite a nice pattern to use. Okay, so in Qt, what are we going to do? One of the things that you're going to have to tame in our threading problem is this guy here, right? He has two identities, and he can be a nasty guy if you get sort of surprised by him. You've got Dr. Q object, right, with his nice signals and slots that are all very handy. But unfortunately, when we originally implemented QThread, we decided it was going to be a Q object, of course. And, well, you know, I create some thread myself, but I'm also an object receiving signals and handling them in my slots. So this got very confusing, and you would see people writing code like move to thread this, trying to get this guy under control. I'm going to show you some ways to deal with this monster. One of the things that I would like to mention is that we do have some good thread-safe functions in Qt, and QObjectConnect, emitting signals, the process events call, these are all thread-safe functions. So if you've got some kind of heavily multi-threaded application where you're tearing down connections and so forth in your threads, these are all thread-safe. A lot of stuff that deals directly with the guts of objects is not, and we can get into some traps with Mr. QThread here when he tries to alter object ownership and stuff. So what I would want to say is, if you remember one thing about this, is do use signals and slots in your threaded Qt applications, because what happens when you do that is, if anybody's attended the training, there was an all-day training on this topic that I'm trying to deal with in a minute or two, but Qt has its own structure for dispatching asynchronous signals, and this is one where it's to a slot in another thread. It actually internally has a queued structure, and it will serialize value objects out of the end of your signal, queue them up, waiting to be dispatched to a slot in that receiving object in the next thread. So you get your queuing for free. And signals and slots, as I say, a lot of the stuff to deal with them are by nature thread safe. Process events can be important, because sometimes what you want to do is make sure that your signals and slots are actually going to get dispatched, which only happens if you've got the event processing happening, so you can drop that call in there. So how do we tame this guy? This is the problem of the wrong thread, right? I've written this code, and what the hell is going on? Somehow my slot is being executed in the wrong place. Of course, the way we should think of this is that slots actually run in the creating thread, unless you call them directly, so don't do that. If you're writing a threaded application, you know, I suggest don't just get hold of a pointer to the object and call that slot directly. Use your signals and slots, and then you can be fairly sure that they're going to get executed in the correct thread. And the reason that's important is because often your slot is going to alter data on the actual object. So here's the recipe I use. If you've read some articles by Brad Hughes, he talks about a different approach. Either of them are quite valid. I like this one because it avoids me having to use the move to thread call. Move to thread is not a thread-safe function. It's fine in relatively small applications, but if I'm disconnecting a lot of worker threads and managing stuff, move to thread can trip you up. What I like to do is actually create my objects inside the run function. This is what the Qt documentation will tell you to do. I don't have time to actually show you the code, but you'll get the link to it. But what this gives you is thread affinity for free. Your object gets created on the stack inside your run function immediately before the exec call. After exec finishes, the run functions exit, and your object naturally cleans itself up. If you've done move to thread, you have to manage the lifetime of those objects, because the thread that you moved it to, if that guy disappears before the object does, you've got problems. So what I want to suggest that you do is just simply create objects inside the thread that their slots should run in, which means inside that run function. Just a little bit of stuff here. This is a bit of this theoretical stuff, so I'm going to really breeze over this pretty quickly. There's this critical section concept, and the idea there is, well, really what we've heard is true, that the concurrency problem is all about access to data. I've got one piece of data here, two threads of control are trying to access it. That's where we run into problems. But then we read some textbook or some article and it's saying critical section. Oh dear. Well, you know, that's really about assumptions in your code, like this loop here. So what I've done is I've coded up some kind of slot and I'm iterating through and I'm frobnicating or doing something to each item in this list. So the assumption here is this list is not going to change. So I have to create some big horrible lock for this whole critical section of code. So critical sections really come about when you've got something that you want everything to stay the same while you do all this complex processing. Maybe you're loading some image and you change a few structures as you loop through some stuff. There's a better way of handling this, which is to actually get rid of that guy and replace it with something that you create on the stack. Put this thing inside a private slot that can only be called from the event loop of that thread. What that does for you is all of a sudden the ability to have that stuff get changed is not going to happen. You can't enter that code and then have control taken off you and re-enter it again from different threads. Access to that private slot is just going to be serialized by the event loop. So it's pretty nice. Suddenly a lot of these problems just go away. So I'll just look quickly at the structure of the application that I showed you before. The way I built it was I have at the top left there a node that represents each of those photographs flying around in space. We have our image manager, which is our back of stage guy telling everybody what to do. He sort of lives between these two things. And when he runs, he creates, well, you can use the Qt thread pool. Just for sort of educational purposes, I went through the process of creating my own thread pool so you can look at the code and see how that's done. But he creates the thread pool on the stack. So that thread pool is automatically going to live in the background thread there, and it's going to be our back of stage guy doing all of this work and not actually blocking the UI. The GUI sends out a signal, and what I've done is I've double handled our signals. This is quite a nice little technique. If anybody's never connected a Qt signal to a signal before, you can do that. It automatically forwards it on. And the result of it, of course, is that slot is going to get executed in our background thread very nicely and not block the UI. Thread pool, he sends that to some loaders, which load up our image and then send it back. Very nicely again, our image is passed as a value object. Because the image uses implicit sharing underneath, you might think that it's going to be very costly to ship all this stuff, serialize it across the signal and slot connection. Well, it turns out it's not. It just handles it across and then it gets ownership on the receiving side there, as long as you don't call any non-const methods. Okay, some do's and don'ts. I won't drill into this slide too much. Lock close. What I mean by that is if you ever have to create some locks, just do it around a little bit piece of data where it's absolutely necessary. Ideally, use some atomic data. Obviously there on the CPU, depending on the actual machine, that may result in the actual implementation doing some locking, but it's going to be much finer grained. Obviously, don't lock in the GUI thread. This is, part of this little documentation. I was saying, just try to set things up so that you're not going to do something potentially expensive inside your GUI thread. You don't know that lock might, even though it's doing a simple operation, chances are that thread could get hung up on some operation and take for a while. You've already seen a bit of the demo, so I won't dwell on that, and I'll go straight to questions. Wait for the microphone to come through. Just while that mic's being set up, at the top there, you can either scribble that down or download the presentation. That's the link to our 3D project, and you can download the source code for the app that I showed today. And you can also send me some email. I'd love to get stories of anybody trying out our code. There's also some great references there. The distributed programming book is, out of all of the ones I've got, it's just a nice little slim volume, pretty accessible.
What I haven't understood is why is Qt mathing with OpenGL? OpenGL is even more portable, so I can use 95% of my OpenGL code in an iPhone, in an Android, or in a Symbian phone. But when I link it or infect it with OpenGL code, I can, or I have to work over it for an Android, for an iPhone. So why is there why does Qt mess with the OpenGL?
So you think OpenGL, the way it is right now, is portable?
Yes, I'm developing an application and it is that portable. OpenGL ES is nearly 100% portable.
Okay, so you can take your shader-based code and run it on fixed pipeline only?
Between an Android and an iPhone, and we develop now for 2 Symbian phones. We only have to the memory management we have to extend, but that's 5% of the code.
Even some of the Vertex, the function names are quite different. You've got problems with data sizes. With QGL Shader, for example, you'll see those high P, medium, low P, those things. That's dealing with some of the differences in data sizes in shaders across desktop versus embedded platforms. If you pick out a few different platforms, there is relative portability, and OpenGL was designed with portability in mind. But I think the reality is that if you're going to develop an app that's going to run on, say, Windows, Mac, and my N900, you're really not going to be able to use the same OpenGL C calls. GL Vertex F versus GL Vertex X, especially if you've got GL 1.1 or OpenGL, the earlier versions of OpenGL. I hope that answered your question. I think there is some value in the portability problem. So that's what we started out with Qt3D. So have you experienced Qt3D? Have you had a look at it? Right, okay. Was that yawning or was that a question? Any other questions? I think everybody's stunned. No, we've got one in the front here.
Does this work? Yep. So, again, about this portability issue, yep. When you're using Qt3D, how do you handle different devices that, for example, don't have also the same hardware capabilities? The biggest difference, for example, are the portable devices that don't have the shader pipeline graphical processors, but don't have fixed pipeline graphical processors. Mm-hmm. How do you handle this when you're using, for example, shaders or something like that?
Okay, so what we do is have our own shader-based implementations for all of the traditional fixed function pipeline lighting models and everything inside of the Qt3D distribution. And we have those shader-based implementations set up so that they will compile for desktop platform and for embedded devices. So what this means is that we can detect from the tool chain whether or not we've got fixed function or shader-based, so ES 2.0 versus earlier versions of ES. And based on that detection, we decide whether to throw out our shaders or include them. And a similar sort of thing happens on the desktop. It's just turning into a Qt3D presentation, but I don't mind that. Any other questions? Thoughts? Comments?
I've been looking a little bit into the OpenGL part of Qt.
Yep.
And I'm just wondering if there isn't any plans on going forward with that, or what's happening?
Have you seen our experimental OpenCL stuff? Yep. There hasn't been too much more work. It was our team that came up with the OpenCL stuff originally. OpenCL can be nice with OpenGL because the data that you're operating on is already on the GPU. So if you're using the GPU to run that OpenCL code, it can be quite nice for manipulating images and stuff. Really, that's about as far as we've really got with it because OpenCL on these devices, even though it theoretically works, like you should be able to use the DSP and so forth, it's sort of just a little bit clunky just yet. And we're busy trying to get our release out. So OpenCL stuff is certainly not dead. It's an active part of our lab's idea, and we'd be interested to hear from you if you've got some use cases for it. Anybody else? How are we going for time? Okay.
I have a short question about the Qt state machine you used in. Do you know how the memory footprint of that is for smaller devices like older Symbian devices? Is it a performance issue, or does it work quite well?
As a rule of thumb, each of these states is really just a Q object. So if you're making decisions about the overhead of Q objects versus sort of smaller value type objects, that's the sort of overhead you've got. Obviously, dispatching signals and slots has a cost overhead on compared with straight function calls. You probably don't want to be in the position where you're creating many states or creating states on the fly. They're much more suited for a type of programming where you set up your application states at the beginning and your application's dictated by moving between them. But the overhead is really no greater than traditional programming with Q objects as far as I know. Animations, yeah, similar again. Each time an animation fires, you're probably setting properties on something, so you've got a little bit of cost there in dispatching the signals and slots.
Okay, perhaps another question on threading. We found threading very useful. We use it. I'm embarrassed to admit that we get it wrong from time to time.
Yeah.
And we found it essential to have debugging and verification tools for threading. One of those tools is the thread checker by Intel, which is vastly useful, we found. The downside is it's ignorant of the Qt synchronization primitives like the Qt mutex. As you've made friend with Intel quite recently, I was wondering whether there's any plans on working with Intel to have the tool recognize your synchronization primitives?
I'm not aware of any initiatives like that. Intel does a pretty powerful concurrent programming library, actually, and it has occurred to me to sort of experiment with some of these things. I guess part of the problem is, you know, we're pretty focused on the GCC toolchain and more accessible utilities. Sometimes, of course, your desktop platform comes with tools. The Mac has some stuff for accessing threads, but yeah, the creator guys are, you know, moving ahead pretty rapidly, and the structure of Qt Creator is such that you could code up plugins and stuff. So maybe we could talk to the Intel guys now that we've got this closer relationship about creating some Creator plugin to expose something like that. That would be pretty neat. Yeah.
Great, thank you.
I hope that's probably not a very good answer to your question, but
well, yeah, the question basically in short form was whether somebody from Nokia could work with Intel to just recognize your primitives because they don't know them. They don't.
Send me an email about that, because that could be something that'd be worthwhile to start happening. So I do want to see more use of threading. Our QThread class has changed a lot over the years, and just recently I think it's gotten a lot better than it was. But we do need to pay more attention to our threading primitives to make it a lot more of a first-class citizen. And I think that would mean creator integration happening a lot better, and maybe integrating with some of these other tools.
Yeah, just perhaps as a small hint, what we did, we've patched the Q library, which is kind of an extra effort to use the standard mechanisms, and that allows Q thread check, the inter-thread checker to give valid results. And it's very helpful.
Oh, nice, cool. Okay, there was one more over here, I thought. One in front. Okay.
Something less advanced, maybe. A bit on design. I was just thinking, what's your sort of take on saving the state of an app when closing it, and sort of resuming in that state which you left off? If you have a simple, like you had this 3 mode, so if you would close the app while viewing a picture,
yeah,
and then when you bring it back, should you be there again, or should you be in the initial mode?
That's a really good question, actually. It's not something I've given a lot of thought to, but if I was going to try to do something like that, you could create a Q settings object, yeah, and define a way to serialize all of the values of where your state machine was at. That would be a little bit irritating because there's not a really good way to interrogate a state machine for its current state. It's got this model where it wants to push notifications out. So you would have to have some kind of plug-in object that just connected up to all those signals to capture the current value of the state machine and record it into an object that you could serialize out to settings. What that did do was it made me think, with this threading issue, if you do get excited about downloading the code I've written, one of the things that can be really nasty is closing down a threaded application, and you sort of have to just go backwards in time when you're doing that. And a nice way to do that is with, again, with signals and slots. So the last thread that got created, as that executes and finishes, it's going to send a finished signal out that then allows other processes to finish. So really with threads you can get a nice elegant exit, and maybe you could have some kind of settings object that would capture the state of those threads as well. All right, well, I think that's it. Thanks very much.
I just have a couple of quick announcements. Lunch is going to be served over in the Winter Garden where it was yesterday. Also in